So here in this problem, we are given that the sum up to the pth term of an arithmetic progression has a value a, the sum up to the qth term has a value b, and the sum up to the rth term has a value c. Then we need to show that the following proof is true. So let's begin. Now, we'll first consider the first term, that the first term be represented by letter A in uppercase, and since it's an arithmetic progression, we'll also consider the common difference to be represented by the letter D in uppercase. Now we know that sum up to the nth term of a given arithmetic progression is given by n over 2 multiplied to 2a plus n minus 1 times the common difference d. So using this, we will now express our sum up to the pth term. So this will be equals to p over 2 multiplied to 2a plus p minus 1 times the common difference d. Now the sum up to the pth term, that's given as a, so we have a equals to p over 2 multiplied to 2a plus p minus 1 times the common difference d. In the next step, what we'll do, we're going to multiply both sides with 2 over p. We're multiplying with 2 over p on both sides, and this is going to cancel out p over 2 from the right hand side of our expression. That means we now have 2a over p. This will be equals to 2a plus p minus 1 times the common difference d. Now what we'll do, we have an a over p expression on the first term of our right and left hand side of our expression. So what we'll do, we are going to multiply both sides with q minus r. So let's do that. So this is going to give us 2 times a over p. So here we have a over p, which 2a over p, which can be replaced with 2a plus p minus 1 times the common difference d. So this will get multiplied to q minus r. So let's multiply them. So we're going to get 2a plus pd minus d multiplied to q minus r. So we have 2a multiplied to q minus r plus pd multiplied to q minus r minus d multiplied to q minus r, which is going to give us 2aq minus 2ar plus we have pdq minus pdr minus dq plus dr. So this is going to be the expression for 2a over p multiplied to q minus r. So let's label this as equation number 1. Then we will use, so here we have the sum up to the qth term. This is given by p. The sum up to the qth term, this will be given by q over 2 multiplied to 2a plus q minus 1 times the common difference d. So here the sum up to the qth term, that value is equals to b. So here b equals to q over 2 multiplied to 2a plus qd minus d. Now we can multiply both sides with 2 over q. So we'll get 2b divided by q, which will be equals to 2a plus qd minus d. Now what we'll do, let's look at the second term of our expression. So here we have b over q multiplied to r minus b. So what we'll do, we'll multiply 2b over q to r minus b. So this is equivalent to 2a plus qd minus d multiplied to r minus p. So let's multiply it, and this is going to give us, let's label this as equation number 2. Then we finally use that the sum to the rth term is given by c, and this is going to give us 2c divided by r, which will be equals to 2a plus rd minus d. And then we're going to multiply 2c over r with p minus q, and this is going to give us, so we're going to label this as equation number 3. Now what we'll do, finally we're going to add equation number 1, equation number 2, and equation number 3. Let's do that. So we're going to get, so we have on the left hand side 2a over p multiplied to q minus r plus 2b divided by caq multiplied to r minus p plus 2c over r multiplied to p minus q. Now here we will see that a couple of terms will get cancelled out on the right hand side. So we have 2aq and negative 2aq, negative 2ar, positive 2ar, positive 2ap and negative 2ap. Then we have pdq and negative qdp. We have negative pdr, this will get cancelled with positive pdr. Then we have negative dq and positive dq, positive dr, negative dr. Then we have qdr minus rdq, dp and negative dp. So we see that the entire expression on the right hand side goes to 0. And finally we're going to divide each term on the both sides with 2, and this is going to give us a divided by p multiplied to q minus r, plus b divided by q multiplied to r minus p, plus c divided by r multiplied to p minus q, and this will be equals to 0. Hence